Okay, so another question we could ask is, you might be given a couple of these different molecules, like maybe you're given, let's say, ethanol and methane, okay? And you're asked to tell which of these has higher intermolecular forces. Which of these molecules is more strongly attracted to each other, the ethanols or the methanes? Well, you know that it's harder to melt something if it's really attracted to itself, right? Whereas if something's has easier to melt, then it's going to have lower intermolecular forces. It's not going to have a strong attraction to other molecules. So the first thing we look at, this melting point, ethanol melts at negative 114, methane melts at negative 182. So this is actually a lower temperature. So methane, according to the melting point, would have a less attraction and so easier to melt. So far this looks like the lower IMFs. Let's check the boiling point as well. So for methane, negative 161. So this stuff is totally a gas at room temperature, right? This boils into a gas well under room temperature, negative 161. What about ethanol? Ethanol doesn't boil till 78 degrees Celsius, right? So that's a little bit less than water's 100, but its room temperature is around 25. So you do have to add a lot of heat energy to get these ethanols to separate from each other, which means they are more strongly attracted to each other than methanes are. So ethanol would have the higher IMFs, and methane would have the lower IMFs. So we can tell that because it's really, really easy to separate methane molecules into gases, and it's quite a bit harder to separate ethanol, okay? So that's how you tell. So the lower the IMFs, the lower the boiling and melting points. The higher the IMFs, the higher the boiling and melting points, okay? Okay, and then here's another thing kind of related, right? So boiling is like when you go from a liquid to a gas. So we have two containers of liquid here, and they're just kind of evaporating. And we notice that these teal atoms are evaporating easier and more often than these orange ones. So we'd call teal volatile and orange non-volatile. What does that mean? Well, it's based on their vapor pressure. So it indicates how volatile a given liquid is or how easily it evaporates. So we notice that the blue ones or the teal ones are evaporating easier. What do you think this means for their intermolecular forces? Which one of these do you think is more attracted to other molecules, the teal or the orange? Hopefully you're thinking, well, if the teal can just jump out and leave this easily, it must have low IMFs. It must have low forces of attraction between each other, which means the orange would be higher. Well, how does this affect their vapor pressure? Well, think about it. If the vapor pressure is how much pressure they get from evaporating, the blue is the only one that even has very much vapor pressure here. The orange doesn't. So if one of these chemicals was water and one was ethanol, the one with the lower vapor pressure is the one that's staying in the container and not evaporating. So orange would be our water at 2.33. Ethanol has a higher vapor pressure, 5.85. That's because it's actually evaporating even at room temperature really quickly. So which one of these has higher intermolecular forces? Well, the one that doesn't want to evaporate and has a low vapor pressure is the one with high intermolecular forces. They're sticking together and they're not escaping out. So the ethanol would have lower intermolecular forces. The water would have higher, right? So vapor pressure, as vapor pressure goes up, then that means the IMFs are lower IMFs, okay? So that's the main idea here, right? So the easier it is to evaporate, then the less strong the forces are between those molecules, right? Easier for them to separate. All right, here's another one. Again, this should make a lot of sense here, but right, we've probably all seen these bugs before, these little water striders. They're able to stand on the surface of the water. And the reason they're able to do that is because water has a high surface tension. Well, what causes this? Well, think about it. When we look in a pond of water, we're really looking at millions and millions and billions and trillions of atoms. And then what would cause there to be more surface tension? Well, hopefully you're thinking there must be stronger forces between those atoms, right? So those forces, those intermolecular forces holding the waters together create that surface tension. So now when the bug stands on it, there's a force holding the water in place. So for surface tension, this should make sense. The higher the intermolecular force, the higher the surface tension, okay? So for example, acetone has a lower surface tension than water. If you put these bugs on acetone, they would actually sink right through it. And there's actually a quick demo to show the vapor pressure of acetone, which is related again to its surface tension as well. So we have some acetone here. I'm just going to go ahead and take a little bit. Just going to take a little bit there. Okay, and then I'm just going to make a few drops of it right there. Okay, so that's our acetone. And then I'll also take a little bit of water. Right, so water sticks to itself better than acetone does. It has higher intermolecular forces, and so what we would expect is that water would evaporate slower and acetone would evaporate faster. And this is because the water molecules in this droplet are sticking to each other really well, and the acetone molecules are more likely to leave because they have less force of attraction. So I'll let that sit there for a second, and then we'll come back to it. But again, all back to those intermolecular forces. Oh, I guess that's it. So let's just go back to it now. Okay, so we can kind of see, yeah, see how quickly those acetone tendrils dried, right? See the water's still there. Let's make a few more. Yeah, I can't even make them anymore. So yeah, this is basically all evaporated by now. It still looks dark, but it's pretty much all evaporated. Whereas the water still has a long, long way to go. This will last for a long time. So yeah, acetone's completely evaporated. So again, low intermolecular forces, evaporates easily, high vapor pressure, low surface tension. High intermolecular forces, does not evaporate easily. So low vapor pressure, and basically has high surface tension, so you can fit things on top of it.